Hi guys, welcome to our very first video for algebra. We're going to just start in right away looking at Chapter 1. Chapter 1 is going to talk about the foundations of algebra. This should really be a review from pre-algebra, so hopefully you'll feel very confident with this information. Looking at Section 1.1. Section 1.1 is about variables and expressions. And first thing that we're going to do is we're going to look at some vocabulary. And you're going to notice as we go through our notes in all of these chapters, we're going to hit the vocabulary pretty hard. So expect us to take a lot of vocabulary notes. First word that we're going to talk about is variable. Variable is a letter that represents an unknown quantity. And I have some examples there. The letter N, S, T, A, B, and X. These are very common variables. There are definitely more variables that you could use, but I just wanted to give you some examples in your notes. Hopefully this is something you've seen quite a bit last year and you're comfortable seeing those, and then definitely when we're done with Algebra 1, you should be even more comfortable. Next word that I have for you is algebraic expression. This is going to be a mathematical phrase that contains one or more variables. Okay? Some examples that I have written down are 5t, and then the example 4u plus 3n plus 7. Notice in each one of these examples, there is a variable in both of those phrases. You need a variable in both phrases for it to be considered an algebraic expression. If it doesn't have a variable, we are going to then call it a numerical expression. So what I have written down here, when an expression doesn't contain any variables, it is a numerical expression. Your textbook gives a definition for this, and we're not going to write a formal definition, just going to put this nice little note in our notes for that. Okay, so we have 2 vocabulary words for this first section. So let's look at some concepts that we're going to be learning. First one is writing an algebraic expression from the word phrase. Okay, so this is really more common terms, translating words to numbers. That's what we're going to be looking at. And our first word phrase that we have is 8 times a number n. Okay, we want to take this and write an algebraic expression for it. Okay, when you're doing this, look for some key words. If I'm looking at this example, times would be a key word. So I like to go ahead and underline keywords that I see in different phrases. And then you choose your notation. I'm going to underline my keywords and maybe put a box around numbers or variables. That's also important. So I have the number 8. And then notice it says the number n. N isn't a number, but it stands for 1. So n is going to be our variable. Okay? So now that I have some key things boxed and underlined, I can now write my algebraic expression. Times means to multiply. That's a fairly easy word to know the math operation that goes with it. So our algebraic expression is then going to look like 8n. A number next to a variable means to multiply. You're not going to see a multiplication symbol in between a number and variable. You're going to start seeing them next to each other. Okay, so make sure you're comfortable with this idea. If not, just practice it, keep looking at it, and hopefully it gets better. Our second example for this is the product of 4 and the sum of a number x and 7. Okay, a little bit more to this example. So going ahead, underlying some key words, and those are really, to me, going to be those math operations. So the first thing I see is product. I'm going to go ahead and underline product. I also see the word sum. And those are the only 2 words that I can really see. But one thing I do want to point out, in class we're going to do a grade activity so that you are really comfortable with words and what they mean. But I'm going to take the word sum and continue this underlining. I'm going to underline the sum of. Because when you see something like the sum of, you're going to think parentheses. Okay? Go ahead and put a box around my numbers. I have 4, x is my variable, and 7. Okay? So now writing our algebraic expression, the product of 4 and, so I need the product of 4 and something. I'm going to put a multiplication symbol in there for now. This is the sum of, I said before, think parentheses, x and 7. Now, notice I do have a multiplication symbol between the 4 and the parentheses. Reminder, you can also write this without a multiplication symbol. And again, this is how you're going to be seeing it. The 4 is going to be next to it. That is also an acceptable answer for this example. Okay, let's flip things around going the other way. Writing a word phrase for the algebraic expression. Our first example is 10x plus 9. When we're doing these, you may have a variety of answers. Your answer may look different than mine. It may look different than your neighbor because there's more than one word to mean a mathematical operation. So don't feel bad or don't feel you're wrong if you have something different. So when I'm looking at this, I'm going to keep it simple. I could write a really complex word phrase, but that's definitely not needed. 10 next to a variable means to multiply, so I can say 10, writing out the word 10, times, we're going to say the number x. That way we know we're talking, or we mean x to be a variable. So the number x, and then I can't say and 9, because someone may interpret that to be 10 times the number x and 9. So we take 10 times the number x, add 9. Okay. That's just one way to write that algebraic expression as a word phrase. Okay. Our last idea that we want to look at today, this is going to be more applying it. So we're going to be writing a rule to describe a pattern. A rule, in math, we're not going to use words to write a rule. We're going to write it as an algebraic expression. So maybe if we want to write rule, I'm going to make a note here, rule. So another word for rule is algebraic expression. Kind of tiny. There we go. All right, so let's look at our example. Okay, so here we have a picture. This came from your textbook. You'll find this online. In this picture, we have a table, and on top of the table, those are cards. They're standing up cards, and notice it doesn't look like this person is quite done. They may add many more rows. So what we want to do is write a rule for the height of the table and cards. So in order to do this, we need to think which value is changing, if there's a value that changes, and what stays the same. Well, looking at that, I can clearly see the height of the table is not going to change. It's going to be 24 inches. So when I write my rule, I'm going to write 24. And if I'm finding the height, I'm going to add the height of the table to the height of the cards. So I'm going to take 24 plus, I need to add the height of the cards. Now, I've already said it looks like he or she is still adding on more cards. So the levels may change, but notice each card is 3.5 inches tall. So depending on the level of cards, that's going to change the height of the table and cards. So in order to represent that, we're going to write down the height of the cards, which is 3.5. And then we're going to use a variable to represent the number of levels. Because then we can input, hey, maybe there's 5 levels. You can put in a 5 for that variable. Or maybe there's just 4. You can put that in. So I'm going to use the variable n. But I need to state, what does that n represent? Okay. So to do that, I'm just going to write down here below, n equals number of card levels. Okay. And that's it. I am done. I have written my rule for the height of the table and cards. 24 inches represents the table, and 3.5 inches times the variable represents the cards and the different number of levels.